As we start chapter 8.1, we get into exponential functions. These are going to be a little different than anything we've graphed or talked about this year. So far we've done lines and quadratics and cubics. Exponential functions, the graph looks quite a bit different, and then how we go about graphing them and what they mean is different as well. So exponential functions, how do we know if the function is exponential? Where are the asymptotes in an exponential function, and how do we graph these functions? So because there is a variable in the exponent, in this case, the most basic exponential function would be like f of x equals b to the x power, where b is a positive integer other than 1. So this is what's classified as an exponential function. There's a variable in the exponent, and b is a positive integer other than 1. So we look at the example right below there, f of x equals 2 to the x power. This is an exponential function because where b is 2, 2 is not 1, and then we have a variable in the exponent. So if we were to graph this, we'll talk about end behavior in a second, but let's look at the graph. If we were to graph this, let's put 0 in the middle here. Okay, and we'll do -1, -2, +1, +2. Actually, I'm going to add in +3 below this. So if we were to type this in our calculator, right here we would get y equals 2 to the -2nd power. And if you type that in, you would get 1/4 or 0.25. The next one, you would get y equals 2 to the -1st power, which would give you 0.5. Then you get y equals 2 to the 0 power, which is 1. Y equals 2 to the 1st, which is 2. Y equals 2 to the 2nd, which is 4. And then lastly, y equals 2 to the 3rd, which is 8. So we were to graph this, we would have -2.25. That would be right about here. And when we have decimals, you just kind of roughly put them where they should be. -1 is up at 0.5. 0 is at 1. 1 is at 2. 2 is at 4. And 3 is at 8. 1, 2, 3, 4, 5, 6, 7, 8. So this exponential function is going to come down. It is going to curve and flatten out. It's going to look like this. Okay? And what we have here is there's an asymptote. Make it blue. There's an asymptote here where that red line will never cross. Well, actually, let me erase that because it's more like this. There we go. So this asymptote is an imaginary line that our graph will never cross. So over here, if I zoom out, you can see the graph. The end behavior, which we kind of talked about earlier this year, just means where is the graph going. So as the graph goes to the right, it goes up. And as the graph goes to the left, which would be -infinity, f of x, which is also just y, approaches 0. So you can see as our graph goes to the left, it kind of flattens out by 0, and as it goes to the right, it goes up to infinity. So we have an asymptote at y equals 0. And again, this new word, this just means an imaginary number that our graph never crosses, or an imaginary line the graph never crosses. We're going to talk more about that here. So the general exponential function will look like this. Y equals a times b to the x minus h power plus k. And a will vertically stretch or shrink our graph. If a is greater than 0, the graph is above the asymptote. And if a is less than 0, or negative, it is below the asymptote. H moves the graph left and right, just like it did with our square root function. And k moves the graph up or down. And the asymptote is always at y equals k. And the domain, which is the x values, is always going to be all reals. And the range is y is greater than k if a is positive, and y is less than k if a is negative. So that is the general information about these equations. We're going to graph a few more and talk about the domain, the range, and how this h and k kind of shifted. Okay, if you got to pause, go ahead. I'm going to slide down to the next one. So just graph the function on the grid at the right, identify the y-intercept and the asymptote, determine the domain and the range. Okay, so some of you are probably wondering, how do I pick my x values? So what I would do is I would recommend putting h in the middle. So in this case, h is what's subtracted from x. So if you look up here, there is nothing subtracted from x. So that means h equals 0 and k is also 0. So I would put 0 in the middle somewhere. So I'm going to put 0 here, -1, +1, and +2. And we'll see if that works. Okay. And I have the y-intercept over here. The y-intercept is always where x equals 0. So if we do the math here in a calculator, if we plug in -1, it'd be 3 over 2 times 3 to the negative first power. We will get 0.5. If you plug in 0, you would get 1.5. If you plug in 1, you would get 4.5. If you plug in 2, let's see, you would get 13.5. Okay, so that's our table. Let's talk. The y-intercept is 0, 1.5. Okay, the asymptote is always y equals k. So the asymptote is y equals 0. The domain, we said above, is always all real numbers. Okay, and the range is going to be either y is greater than k or y is less than k. In this problem, 3/2 is positive. So it's going to be y is greater than k, and k is 0. So it's y is greater than 0. So if you come over here and graph it, -1 is at 0.5. We have 0, 1.5, 1, 4.5, and 2, 13.5, which is going to be way up here. And I got ahead of myself there. I should actually put the asymptote on here first. The asymptote is at y equals 0. That means this graph will not cross that line. So it's going to come down, and it's going to flatten out real fast. Like that. Okay, so it's kind of flat along that y equals 0, that blue line, and then it goes up real fast. Okay, let's try example 2. Let's find out what h and k are. Actually, we should do a, h, and k. So a is -2, h is 0, and k is 0. Again, because if you look at the equation, there's really nothing added. It's really x plus 0 plus 0. So that's where the h and k come from. Okay, so I would put in 0 somewhere in the middle. So 0, -1, -2, and then +1. The asymptote is always y equals k, so here it's y equals 0. We know the domain is always all real numbers. And if you look, this time a is negative. So our range is going to be y is less than k, so it's y is less than 0. Now I want to point one more thing out. the asymptote and the range will always have the same number because they're always going to go off of k. If we find the y values, we would do -2 times 2 to the negative second power. We get -0.5. Then we do -2 times 2 to the negative first power. You get -1. -2 times 2 to the 0 power is -2. And then -2 times 2 to the first power, which would be -4. So that should be enough to put our graph on here. The y-intercept is 0, -2. That is always when x equals 0, that's going to give you your y-intercept. So if we come over here and put the asymptote on our graph, the asymptote is at y equals 0. If we graph this, -2, -0.5 is right about here. -1, -1, 0, -2, and then 1, -4. So this graph is going to be flat along the asymptote, then it's going to curve down like this. So there's our graph of f of x equals -2 times 2 to the x power. Okay, see how that one was flipped below because a is -2. It was flipped on the bottom of the asymptote. All right, last graph. Let's find out what a, h, and k are. A is +2. H is also +2 because it's going to be the opposite. So the opposite of a -2 is +2. And k is 1. Okay, so the asymptote is y equals k, so it's y equals 1. The domain is always all real numbers because we can plug in any x value we want, positive, negative, or 0. And the range is going to be y is greater than, because a is positive, that's y is greater than k. And again, these will always use the same numbers, the asymptote and the range. So let's put the asymptote on the graph before I forget. The asymptote is at y equals 1. This time the asymptote is up. It's not at 0 anymore. And if you plug numbers in, h should always go in the middle. So since h is 2, I'm going to put 2 in the middle, 1 and 0, and then 3. So if you plug these numbers in, if you plug in 0, it's going to be 2 times 3 to the 0 minus 2 power. On your calculator, that should be in parentheses. And then plus 1. When you plug that in, you should get about 1.2. Then you plug in 1. You should get about 1.7. Then you plug in 2. If you plug in 2, you should get 3. Then you plug in 3. 2 times 3 to the 3 minus 2 power plus 1, you should get 7. So if we graph this, 0, 1.2, 1, 1.7, 2, 3, and then 3, 7. 1, 2, 3, 1, 2, 3. You see how they get really big really fast? That's what happens with exponential functions. So if this is coming down, and then we flatten out. Oops, I missed one. So that's what the graph looks like. And I forgot we should add in that the y-intercept is 0, 1.2. Okay, and that always comes in where x equals 0. Okay, and that's it for graphing exponential functions today.